In example 7 and on page 115, again we are explaining this book, Pure Mathematics 1, topic number 6 and example 7, and we are going to look at an interesting question whereby we need to apply the sine rule keenly and very carefully, because we are told that in triangle ABC, AB is 4 centimeters and AC is 3 centimeters. You're going to draw that triangle, and angle ABC is 44 degrees. Work out the two possible values of angle ACB. And I want us just to have a triangle. Let's just construct a triangle, because a triangle that is talking about two possible angles, we need to be keen. Let's just have that triangle constructed here. Let's just have that line, and that line could be talking about, because AB is 4 centimeters. AB is 4 centimeters and AC is 3 centimeters. So let this vertex be vertex B, so that from here we talk about 4 centimeters. And how do we measure 4 centimeters? We measure 4 centimeters using the compass, and we talk about 4 centimeters somewhere there. Yes, those are 4 centimeters. You can see 4 centimeters accurately, 4 centimeters. And our line, our point A, will be anywhere along that arc. Anywhere along that arc. It will be anywhere along that arc, 4 centimeters. But it is this angle that is going to give us angle ABC. ABC. So C is along this line. Angle ABC is going to be 44 degrees. So using this line, we put our protractor here, and at that particular point, we measure 44 degrees. Yes, there we are, 44 degrees, and this is just like it, 44 degrees. And our line, our point now A, is clearly at that particular point. You may produce the line, there is no problem. We can actually produce that line, there is no issue. This is now confident is actually point A. We are told that AC is 3 centimeters. And we are also told that work out the two possible values of angle ACB. What does that mean? If AC is 3 centimeters there, then there must be two possible points where C lies. And our duty and our responsibility is just to ensure that we have 3 centimeters. Yes, there we are. And from point A, we measure 3 centimeters. From point A, you can see we talk about that. From point A, 3 centimeters. It cuts the red line at that point and also at that other point. So sure enough, we have two possible points where C lies. Yes, we could talk about C can be there, that is, could be C1, and this could be C2. So we could be dealing with a triangle that looks like that, or a triangle that looks like that. So we have, using triangle AC1B and AC2B. But let us just detail up our triangle AB is 4 centimeters. What about AC? This is 3 centimeters, and this is also 3 centimeters. We have constructed it as you watched it. So this is 44 degrees. Having said that, we can easily talk about using triangle ABC2. ABC2. Yes, sine C2 over 4, this angle, is equals to sine 44 over 3. And C2 is the sine inverse of 4 sine 44 all over 3, which is how many degrees? Let us find out that. 4 times sine 44 is equals to, of course, divide by 3 equals to, and okay, let's 4 sine 44 is equals to, divide by 3 is equals to that. Shift sign answer is equals to 67 degrees. So 67.9 degrees. 67.9 degrees. So it is possible that angle AC2B is 67.9 degrees. But look, there is angle. Okay, this is angle. This is angle AC2B is 67.9 degrees. But there is another possible angle, angle AC1B, which is also possible according to our constructions and argument. If you look at that, and the sine inverse of this angle now, or rather the sine of this angle, will be exactly equals to the sine of 67.9. What does that mean? Now we will have to go to the unit circle and talk about 67.9 and 67.9. Remember, this is the first quadrant. All science teachers complaining. And of course, you know the sign is positive in the second quadrant. So the other possible value of ACB is going to be 180 minus 67.9, which is how many degrees? 180 minus 67.9, which is 112.1 degrees. So those are the possible values of C: 67.9 degrees, that angle, and 112.1 degrees, that angle. Those are two possible values of the angle we are finding. And sure enough, note that this angle is acute. This is acute angle, and that is why it is 67.9 degrees. It explains. This angle is obtuse. This angle is obtuse, of course, greater than 190, greater than 90 degrees and less than 180, and that is why it is 112.1 degrees. Quite a tricky question, but very important question. It also reminds you that in some different quadrants, then trigonometric ratios can have different signs. And this one is a very good example of such kind of a question. Again, please visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto, and subscribe and share widely, and of course like. All right.